So this is my video assignment question that what I was assigned. So for this I'm doing question 10 on the May 2009 exam of paper 2. So the question first starts off by saying let f of x equal x cubed minus 4x plus 1, which I've written here. And you're going to be coming back to this every time that you're using the question. It's going to be very prevalent throughout. So you're going to start off with A, which asks you to expand x plus h cubed. So using Pascal's triangle coefficients are now 1, 3, 3, and 1 for anything cubed. So using that, using the binomial expansion, so using that I was able to simply write out x cubed, because what I did was you start with the first term x cubed plus h to the 0, and then you go down in x and you go up in h in order to. So you start off with the coefficient of 1 of x cubed, and then you plus the next term, which has a coefficient of 3, and x squared h, because h went up by 1 and x went down by 1. And then you continue to get 3x h squared, and then finally h cubed. So part B asks you to use first principles to show that f prime is equal to 3x squared minus 4 of the original equation f of x. So in order to do that, we're using the first principles formula of f prime of x is equal to f of x plus h minus f of x all over h. So to do this with the x cubed function, we plug in the f of x plus h part of the equation, which is what you see in the square brackets right here, x plus h cubed in brackets minus 4x minus 4h. And what that was just minus 4x plus h, and I just simply expanded that right away. Minus x cubed minus 4x all over h. You then use the binomial expansion that we used in the previous part A, for x plus h cubed, and then you have all of the stuff expanded within the square brackets, which is what you see here. So then, moving on to the next step, you collect like terms on the top of the bracket there, and you can see the crossing out that I did. You can cancel out x cubed and negative x cubed, and 4x and negative 4x. So you're left with 3x squared h plus 3x h squared plus h cubed minus 4h, all over h, of course. And that's what you see there. And what you can do next is you can factor out the h, because ideally, and the goal of the whole first principles is you want to get rid of the h on the denominator so that you can plug in h is equal to 0. So the next step here, I factored out h and got 3x squared plus 3xh plus h squared minus 4, and then all times h, and I crossed out that h and the denominator h, and was left with what you see there of 3x squared plus 3xh plus h squared minus 4, and I subbed in h is equal to 0, and I got my derivative, which, as you can see here, the 3x to the 0 and the 0 squared both do not count. They both equal 0, so therefore you're left with 3x squared minus 4, which is the same as what we originally started with up here. So then we move on to part C. And part C, it says the tangent to the curve of f at point P, 1, negative 2, is parallel to the tangent at point Q. Find the coordinates of Q. So this is a nice simple question that we get a lot with derivatives, and what you start off with is the formula for the gradient, which is f prime of x is equal to 3x squared minus 4, which is what we got in the previous one. And in order to find the point Q, the coordinates, you first off, because it's parallel, you know that the gradient is going to be the same through both points. So plugging in the x value of 1 at point at point P, you then get the gradient, as you can see from over here on the left hand side. You plug in 1 of 3x squared minus 4, you get 3 minus 4, which equals negative 1. And you sub back that back in to find into the gradient formula to find the other possible value for x. So you get negative 1 is equal to 3x squared minus 4. So you bring the 4 over, plus 4 equals 3 is equal to 3x squared. So you divide both sides by 3, you get 1 is equal to x squared. So therefore x is equal to 1 or x is equal to negative 1. because x squared can be both of those and it's still equal 1. So you take that value for x, which is -1, which is now the value is the x coordinate for q, and you plug it back into our original formula of f(x) in order to find the y value. So as you can see here, we rewrote the f of x formula, x cubed minus 4x plus 1, and then I subbed in -1 for x, and then I solved, and you get 4 here. And so therefore the point Q is at -1, 4. So moving on to the second, so now on to part D, the question says the graph of f of x is, the graph of f is decreasing from p is less than x, which is less than q. Find the value of p and q. So in order to find this, what I did was I used my graphing calculator and I plotted the equation for f prime of x, which is 3x squared minus 4, as you can see here. And the reason why I did this was I wanted to know at what points is the ends of when f prime is negative. Because when f prime is negative, it means that the original graph f of x is decreasing, because it's f prime is just the gradient at any given point. So I plotted it, and you get a graph similar to the one like this. And what I did here was I showed you that the x-axis, the negative x-axis, the one to the left of the y-axis, is point P, and the one to the right of the y-axis is point Q. So in order to find what these actually are, you again use your GDC, your TI, and you press second and then trace, which is calculate, and you press 2, which is 0. So in order to find 0, then you do point to the left of the graph. So for instance, you'd put about here for the left one, and you put a point to the right of the graph, which is about here, for again using it for the left one, and then you press enter, and your graphing calculator will give you a value for x when y is equal to 0. So I did this, and I got the following two x-intercepts of -1.15, 0 and 1.15, 0. And these are rounded slightly, but that is what it gives me. And the reason why they are the same is because there's no horizontal stretching or translation, so therefore you know that it's going to be negative and positive of the same value. So therefore, simply using this, you know that P is equal to -1.5 and Q is equal to 1.5 from the original question up here, where it asks for finding P and Q. So therefore, when f prime is negative, it's between P and Q, which is -1.5 and 1.5. So for part E, it asks us to write down the range of values for the gradient of f. So therefore, f prime of x is negative when 1.5 is less than x, which is less than 1.5, and f prime of x is positive when x is less than -1.5 and greater than 1.5. And also, going with the range of values, the domain is x, can be any real number, and the range is y, such that y is greater than -4 because of the original translation, and y can be any real number within that range. And so that is my question. Thank you.